Oh, okay. Okay, so welcome back. This is Jorge Escobar, and well, I'm learning Python. Um, I'm not learning Python because of I am passionate about it. I really didn't knew too much about Python, but I know that you can make money developing in Python. So and I've been working as a backend developer, and one of my jobs was to write AWS lambdas in Python. Python was a very simple enough language that I was able to figure it out on my own at the start, at least. But because quite easy to learn or to read, may I say. But I am actually learning a lot on this course here. It's my ambition to work as an artificial intelligence or maybe a machine learning engineer, uh, because there is a lot of more money to be done there than as a data engineer. So basically, yeah, I'm doing this because of the money. I want one of my night I recall I was saving money to buy a home and go live with my wife alone, have a family and all that. And well, she died this past February 2022. So, and in the last moments, she actually told me that she didn't want to die. Well, nobody wants to die, I think. But she regretted not doing things, she waited for too long for doing things like having kids and whatnot. And that's one of her big regrets. And I think it's one of mine too. One of the things I want to do before I die is to have my own home, my entire life I've been living in somebody else's room. So either my parents, then I was renting, so I was living in somebody else's room, and I was paying rent, and then COVID happened, and then my wife died, so and now I'm living with my parents again. Uh, so I am being always living in somebody else's house for that matter. So before I die, I want to do that. I want to have my own home under my own name, and maybe try to rebuild my life. Who knows? But for the time being, I'm going to be laid off. I think tomorrow it's going to be official. So my plan is to basically wait up, uh, use this time to learn Python. I want to build something, and the first thing that comes to mind is a website. Uh, just because I ignore what else can you do with Python. That's basically so that's why I'm learning from courses right now, because I want to make something other than a website, because I know that Python can do artificial intelligence, can do machine learning, but other than that, I don't really know how or what or how. Well, basically, so that's why I'm learning. I'm going to invest time learning, and that's what I'm going to be doing right now. So let's see. Okay, so let's try out. There we go. Okay, so what's on with Twitter? Nothing much. Who is this? Ah, okay. Okay. Well, I guess never mind. So, on the last session, I basically took the entire morning trying to solve Fibonacci numbers exercise, and I basically just gave up and just watched the solution. I overthink the solution first, and but I may like to think that that actually helped me to understand how generators actually work and the differences. And one of the main differences between the keyword yield and return, for instance, is that return once you touch that line and it executes, after execution, returns just finish execution for the block, and you then execute anything else. But yield, after sending back the value, it doesn't stop the execution of the function, it just pauses it, which means that you can actually continue execution after the yield statement. So you just yield the value out there outside the function, and then resumes execution after you call for a next donder method, I think. I still don't really understand how it works, but I guess with practice I will keep understanding it more and more. Let's see. So this was the exercise, I believe. Yes. It's in section 10. And it's called 10.3. There we go. So what this program does is to print out the Fibonacci series of numbers. There we go. It prints out the Fibonacci series of numbers, and I was dealing with this for a long time. But basically, this is where I didn't know that the yield can be resumed afterwards. So basically, if I just use a return here, all of this code down here is not going to execute. So that was basically one of my problems, one of my issues. But anyway, I guess I should just add this to copy relative path. Let's add this one. There we go. And there we go. So this was the last file for section 10. So what I may like to do here now is, let's go to the official terminal actually. Yeah, get cd, I think it's called Python, okay. Okay, so I have several commits here. The one on the top, this one here, all of this, from this commit down to this one, all of this is just on my local computer. It's not on GitLab yet, so I'm going to basically create a new pull request, basically, with a push command, git push. And it's going to tell me, you know what, this branch does not exist on your remote. Would you like it to exist? Well, yeah. So I'm just going to copy this code over here. Gonna paste it. It reads git push set upstream origin section 10. Origin is the name of my remote branch, and section 10 is the name of this branch that I'm working on. And now, after doing that, it's going to give me a link to the merge request, because it's not a pull request, it's a merge request. I'm requesting a merge. I think it's with control click. There we go. I'm not going to change anything here, but squash the commits. That's always good practice. And somewhere around here, okay, there we go. Delete the source branch when merge request is accepted. And here are all of my commits, and it's going to squash everything. Squashing is basically picking up all the commits on this branch, compress them into a single commit, and merge that into the main branch. That's basically it. It's not going to create individual commits for every single change. It's just going to create one with all the changes. I do this because it keeps the main branch history clean, basically. I'm going to create a merge request. It's not merged yet, so I need to wait for this to check if the code can be merged. I think it does. Okay, so I'm going to merge. And now that the code is merged, if I go back to learning Python, I can see that I only had one branch, the main branch. So the other branch was just created and destroyed just for this purpose, and that's it. Well, anyway, on my side, I still have the section 10 branch. So what I like to do is go back to git checkout main. Now I am on the main branch, so section 10 is no longer needed. But before doing anything else, I may like to do this git pull. I wonder if I can update everything in one pull. I don't think so. Okay, looks like everything was done. Let me see, remote, unpacking, updating, fast forward, section advanced. So these are the additions and nothing else, I think. Section 10 branch still exists. Okay. I wonder if I can go there. Wait. Okay. I'm going to delete that branch anyway. Git branch dash delete with capital D, section 10, and the branch is done. Okay, no more. Let's check out the git log. Bring one line, graph, and there we go. Section 10 has been merged to the main branch, so I have everything here. So I'm going to create a new branch just now with a git checkout dash B, section 11, and now I am on section 11. Okay, so far so good. And that's it. Okay. I think I need to review generators, error handling, and decorators. Yeah, I'm going to be doing that later. I first want to give a single pass to the entire course. And then I may like to rewatch it in an overview watch and see and review the subjects that I'm having issues with. But first, okay, generators, modules. Oh, this is going to be fun. I guess this is where they teach me how to import scripts into other scripts, and that's something that I think should be teach quite early, actually. But anyway.
Up to this point, we've learned about a few ways to organize our Python code. The first thing we did, well, we just wrote Python in a file, and that organizes it, right? Our entire code has been so far on one single file. So that was one way that we organized our code. Next, we learned about functions, and functions were used as a way for us to not write code that we repeat over and over. We could write functions that we can use anywhere we want in our file, so that we can call these functions over and over, and we can name the functions appropriately so that our code makes sense. And then we learned about classes, right? These blueprints that we can create objects from. We can instantiate new Python data types beyond the ones that they just gave us, right? Instead of just having dictionaries and lists, we can create our own custom ones, our own lists maybe that have extra features. And we're able to use classes to organize our code, to box them up, and give each class a certain method and attribute that packages it nicely for us to use. We also learned about functional programming and how, unlike, let's say, object-oriented programming, where we see a lot of classes, with functional programming, we just use a lot of functions, a lot of pure functions. And we have data that we just pass into those functions. And we organize things into small little pieces. All of these things were meant for us to keep our code clean, make our code more maintainable, thus keeping our code organized. Because as we write more lines of code, it gets harder and harder to keep everything. If other people join your team to work on your project, they need an easy way to figure out how things are working. But we still have a problem. And that problem is that everything is contained in this one file. All the functions, all the classes we've been writing has been on just one dot.
Everything goes there.
In real life, this isn't the case. We have a lot more code. And we can't just have one file with millions of lines of code. So how do we stay organized? Well, if we had multiple files of Python, like this, because our project is getting bigger and bigger, would this work? Is there a way for us to link all of these files together? As a matter of fact, there is. And this is very common practice all across industry. And we call this way of organizing code modules. And modules are simply well, these files. Each one of these files, each .py file is a module. And by building these modules, kind of like we built different functions, kind of like we built different classes, because inside of these files, we can have classes, we can have functions, but we can also have different files, so a layer higher to divide up our code. And in this section, we're going to learn all about modules and try to master it and see how we can write organized code. Let's have a look. You can see over here, if I click on files in our REPL, we have main.py. And every time I click run, this file got run. But what if we have more files? What if I add another file here? And we'll call it utility.py. So based on what I just taught you, these two things are what? They're modules, right? Main.py is a module, utility.py is a module. And when writing modules, we use the same principles as variables in Python, which is snake case. That is, if there's spaces, we use underscore, everything is lowercase. Okay. So how do we divide up these modules? And this comes with practice. When you're just beginning, it's hard to say, hey, what goes into what file, what goes into what file? But similar to classes, right? Similar to functions. We want to divide up our code into chunks that make sense. Again, let's say we're working at Netflix. We might have a file dedicated to videos. We might have another file or module dedicated to the login of a user. Maybe another file dedicated to analytics and figuring out recommendations for users. We want to group these classes and functions together inside of a file that makes sense. Now, one of the most common ways to use a module is something like a utility. Let's say we want to create a utility module. That is a module that has a lot of, well, kind of like a tool belt. Very simple functions that we can use all across our project because we can imagine here having multiple files. So let's create a very simple example. I'm going to say a multiply function exists here, and this takes a num1 and num2. And in here, we're simply going to return num1 times num2. A very simple function. And once again, we'll also have a divide function. And yes, this is kind of useless because we can just use the plus or the divide operand in Python, but stick with me here. I'm trying to show you an example. All right, so num2. I'm going to return num1 divided by num2. Nice and simple. This is our utility module that has all these functions for us. Now, notice here that we're actually not doing anything in this file. I'm simply defining functions, but I'm not running any functions. But let's say we have this utility module, and I want to use it in my main.py file. How would we go about doing this? Well, the way we communicate between these two files is quite simple. All we need to do is use the import command. We import and then give it the file name that we want to import. What do we want to import? We want to import utility, just like that. And notice that I'm not adding the .py because we assume that whatever we're going to import is going to be a Python file. So we don't need to do that. Just the name, just like that. Now let's print utility here. If I run this, whoa, do you see that? Module utility from, and then this is a file path that this website generates for us, so it doesn't really matter. Now, there's a few things that happened here. One is that we generated this py cat that happened here. It doesn't really matter.
If you do this on your computer without a website like Replit, it will be the file path to the utility model. Okay, thank you. Now,
there's a few things that happened here. One is that we generated this py cache folder, underscore py cache. And
what?
Oh boy, what is this gibberish? This is pretty confusing, right? Well, this py cache is created every time we run a file with, let's say, import statements. So when we're using modules. You see, what PyCache does is when we click run, the interpreter is going to create this PyCache folder, and it's going to say, hey, I'm running this file, this one main.py file. Anything that main.py file imports, let's say utility, in our case, I'm going to cache it. So see how here it says .pyc?
So it's pre-compiling something like bytecode.
Remember, this is the C Python, which is the interpreter written in C. So this is actually a compiled file. So that next time I click run here on my main.py, nothing changes. Because what's going to happen is instead of loading up utility.py, it's going to load up this compiled version of utility. Because
it's going to be faster. Okay.
This makes things faster when I try to run main.py. Again, that's what caching is. Caching is, hey, I'm going to remember this, and this is the compiled version, so I don't have to go through the compilation step. But notice that the main.py file does not get compiled because, well, we run it every time. Now, if we change the utility function to not have the divide in there, I click run, and you don't notice it here, but this has now been rerun because we have a different file. You see that we have multiply here, but not divide.
Okay.
Let's bring back divide again. Go back here, click run.
Oh, nice.
And there you go. We have divide here too now. But this is something that we don't touch. This just comes underneath the hood with that we use. And in a few videos, we're going to show you how this also happens when we use something like Pycharm. This is just something that editors allow us to do just so our programs can run faster. So I now have access. Let's make this a little bit smaller. I now have access to utility. And here's the interesting part. If I do dot here, look at that. I have access to divide and multiply. So I can multiply numbers, let's say 2 and 3. Click run. And I'm able to use the utility module in my main file. Very, very cool. If I do divide and I click run, I can use this as well. Very, very cool. And I can import as many times as I want. If I had a different file in here and I want to import another thing, let's say there's a utility 2 file. Well, I can import that and import as many things as I want and use them across my files. How cool is that? So now we have a way to organize our code and have all these files communicate together. Because in real life, we have big projects. And these big projects are going to be worked on by different teams, different programmers. And we need a way to work with all these files. And by using the import statements between modules, we're able to use functionality, just like we were able to use the functionality that functions provided us between different files. And most of the time, if you're working at a company, the first couple of lines on a .py file are usually import statements because usually you're communicating with other files. Let's learn some more in the next video.
Okay. Let's take a little break. Let's try something here. Well, not here, here. Okay. Section 11. What's your name? Modules in Python. But it doesn't read advanced Python, so I guess this is not really that advanced. I guess. Okay, so let's try something first. Let's copy the naming convention for this guy. Utility.py, and let's just create something here. For example, I don't know, def, yeah, some num1, num2, or maybe just an args, and I think I can specify that you're going to return an integer, and just for num in args, yeah, because this is a collection, just sum is going to be equals to 0, sum plus equals to num. And I'm going to return the sum. Okay, let's try to make this a little bigger because I can barely read anything here. There we go. You can read that too. Okay. So sum is going to be equals to 0. Well, why not? Okay, so this is going to be supposedly my utility file. And maybe I can create a new one. And you're going to be 11th underscore 01 underscore imported sample dot py. So, oh, it actually knows what to do. Okay, so let's print a call to the functions. Okay, so I need to do this utility dot sum, and this is a method. This is a function, I mean. So let's say 10, 34, 23, 69, 29, something like this. Okay, something's wrong here. Module utility has no sum member. Is that so? I think I just did, isn't it? I'm missing something. What is it? Let's go back to the utility file. There we go. Okay, you are defining a function. What?
Function. And once again, we'll also have a divide function. And yes, this is kind of useless because we can just use the plus or the divide operand in Python, but stick with me here. I'm trying to show you an example. All right, so num2. I'm going to return num1 divided by num2. Nice.
Okay.
So this is our utility module that has all these functions. Now, notice here that we're actually not doing anything in this file. I'm simply defining functions, but I'm not running any of the functions. But let's say we have this utility module, and I want to use it in my main.py file. How would we go about doing this? Well, the way we communicate between, just like that. Now, let's
utility
underscore PyCache. And oh boy,
something happens.
So it doesn't really matter. Now, if I run this, whoa, do you see that? We have module utility from, and then this is a file path that this website generates for us. So it doesn't really matter. Now, there's a few things.
But I'm not able to run sum. Why not? It says that utility.py has no sum member. Why? That's weird. Okay, let's try to print out utility. Well, that's allowed. Okay. Okay, it's printing the utility and the location of the utility file. But I'm not able to print out the function. Why not? Okay.
That happened here. One is the main.py file. Anything that main.py is, because what's going to happen, notice that the main.py file, any editor that we use. And I'm able to use the utility module in my main file. Very, very cool. And there you go. We have divide here too now. But this is something that we don't touch. This just comes underneath the hood. We're able to use the utility module.
Now he's using it just like that with dot notation. Utility dot sum. I actually see the Pycharm folder over here. Yeah, it's a binary. Okay. That's weird. I wonder if I need to surround this as a string. It actually works, but it's not telling me why I don't have a sum member. That's weird. It works though, so I guess I am okay.
In my main file. Very, very cool. If I do divide and I click run, I can use this as well. Very, very cool. And I can import as many times as I want. If I had a different file in here and I want to import another thing, let's say there's a utility 2 file. Well, I can import that and import as many things as I want and use them across my files. How cool is that? So now we have a way to organize our code and have all these files communicate together. Because in real life, we have big projects. And these big projects are going to be worked on by different teams, different programmers. And we need a way to work with all these files. And by using the import statements between modules, we're able to use functionality, just like we were able to use the functionality that functions provided us between different files. And most of the time, if you're working at a company, the first couple lines on a .py file are usually import statements because usually you're communicating with other files. Let's learn some more in the next video.
Okay. Packages. That's not the same thing, I guess.
We just learned about modules, but let's say our project is getting even bigger. We have this main file, you have some utility, but let's say that we're now working for Microsoft and we have a new, let's say, shopping functionality, an entire, let's say, shopping area where you can buy Microsoft t-shirts.
Okay.
Well, we can now create a folder, so we can add folders to our project. And inside of this folder, let's say we have a new file, and we'll call this the shopping cart.py. So now the shopping cart.py is a folder in our project. You see that our project is getting bigger and bigger. And let's say that here we just have a function called buy, and we give it an item. And let's say here we have a cart variable that, let's say, adds. It's not a very sophisticated buy.
Yeah.
For our example, it should be fine. And then we just return the cart.
Okay.
Now in here, we have this buy function. And let's say in our main file, so up here, we want to also import our shopping cart buy function. How can we do that? Well, if we try to do shopping cart like this, remember that's the name of our file. You see that I get an underline that says imported but unused. Okay, so does that mean use it? Let's see. I'm going to say shopping cart, and if I click run, module not found error, no module named shopping cart. You see, what we've created here is what we call a package. A package is simply a folder. And we learned about module, which is these files, these Python files. A package is a level up. A package is a folder containing modules. So you have a package with multiple modules inside of them. So this shopping cart is a module, but this shopping is a package. So the way it works when we import from a package is we say the package name. So what's the package name?
Shopping.
It's shopping. And then we do a dot.
Okay.
So package name and then the module name. Now if we do this, let's see if this works. Let's say I do shopping dot shopping cart. If I print this, let's make this a little bit smaller. All right. Now I have access to the shopping cart module by importing the package shopping, which is the folder, and then the shopping cart. And you notice once again,
folder,
that was created for the shopping cart.
Oh, it's
so let's see if we can use the buy function. So I'm going to say buy, and then item, I'll say I'm buying just an apple. If I click run, there you go. I get my apple, and I was able to import it from a package. Now, here's the thing. I want to try and copy what we've just done into a real-life scenario. Instead of using this website, repl.it, let's actually create our own project. I'm going to use Pycharm, and I recommend you use Pycharm as well for these next couple of videos.
I lost video. Wow. Okay.
Let's open up Pycharm, and let's just create a new project here. Now, we can call it whatever we want. So let's just call it modules for now for our project. You can see where it's being saved. And remember here, we get to pick what interpreter we want. We're going to talk about this virtual env later on in the videos, but the key thing is to make sure that our base interpreter is using Python 3. In my case, the Python 3 that we've downloaded in user local bin. If you're on Mac or Linux, if you're on Windows, this path would probably be different. Now we can just create a project. And we see here we have our modules project. Now we're going to ignore all these folders for now. We're going to talk about them later on. The key here is that we want to create a new file. I'm going to just right click here and say new Python file. And we can just call it, let's say, main.py. And notice here that I created in a folder called VENV. We'll get back to that shortly. Now let's make this a little bit bigger so we can see. And we're going to copy whatever we've just done here. So I'm going to copy the main file like this. Oh, that did not copy. Let's try that again. Like that. And then we're also going to create a few more files. So we'll create a folder. So in here, I'm just going to say right click, say new. And right away, you see that it says Python package. I'm going to click on Python package, or I can create a directory if I want as well. And when I click here, let's name the package like we found here as shopping. All right, we get our shopping folder. And in here, let's right click, say new file, and we'll call this the shoppingcart.py. So shoppingcart.py. And then finally, we'll add our utility file. I know we're doing a lot, but hey, I'm trying to prove a point here. Trust me, this is going to be important. So utility.py. There we go. So we have the same setup that we have here. Let me copy this over as well.
Yeah, the code.
All right. And we copy.
Okay.
Let's make this bigger, like that. Right. So we have our files just like we have in our REPL, except this time we're actually using an IDE. Now, the reason I wanted to transfer over to the IDE is that there's an extra file here that we didn't see in the REPL. And the REPL actually hides this away from us. You see this underscore init.py file, and it's completely empty. There's nothing in here. One of the rules of a package, of a Python package, is that on the root of this package, you have to have an underscore init __.py. Now, why is that? Well, because the interpreter is going to read this and say, oh, this is a Python package. Remember how when I right-clicked here, I said new, and then I had an option of a directory or a Python package? By clicking Python package, it automatically added this init for us. So although here everything worked without a init, this is just something that REPL hides underneath the hood. Anytime you want to create a package, you'll see that we need to have an init file, and it can just be completely empty. Now, the beauty here with Pycharm is that it does it for you, which is really, really nice. Okay, so let's run this code and make sure that it still works. So this is our main.py. I can simply run the code here by going to run, and then selecting run. Let's run our main file. And we get an error. Let's zoom in here. And we see that module shopping.shoppingcart has no attribute by. And
no attribute by.
Import the by function here. So let's do that. Let's go to shopping cart by. Make sure I copy that. Paste it in. Let's zoom that in. And by the way, I'm zooming here on my touchpad. I can just use 2 fingers to zoom in here. If I click run again, and this time once you ran it once, you can just click on run again. And there we have it. We have Apple right here as the output. And it says process finished with exit code 0. In programming, when something exits with code 0, it means there were no errors. If you get 1, well, that's usually an error.
Yeah.
All right, so we have everything working, and this is now our setup. We have our main file. We have our other modules like utility. And then we also have our packages. And they're packages because they have this init file, and we have different modules in them. And as projects get bigger and bigger, and we use IDEs like Pycharm, we organize our functionality, our grouping, into these packages and modules. And really, really good developers are able to organize code in really nice packages that make sense, really nice modules that make sense. This is a skill that is really hard to teach. It just comes with practice, by looking at
not really
working on projects. But the key thing is that you want to do what makes sense. And when we start working on some of our final projects, we have over 10 projects coming up that we're going to work on. Now, with those, we're going to start to learn different ways to organize code and follow along. So don't worry. Let's take a break and explore modules a little bit more in the next video.
Yeah. Okay. So let's wait. What? Different ways to import Python built-in models. Okay. Let me like to practice here a little bit more. Let's say it's going to be a little bit complicated here, but maybe not so much. Okay, let's try something else. What about if we create here a new file called 11_02_ packages sample.py. And before doing anything here, I may like to create a new folder called utilities. And down here, I may like to, well, maybe either copy or copy. Let's copy the sum. And probably I could create another mol and basically just multiply. That's it. It's pretty much the same thing. Okay, but it's going to reside inside the utilities package. So let's go back. Don't need this, don't need this, and I don't need this. And here I'm going to import utilities plural dot utility, and this is the file. I wonder if I can import individual functions. Now looks like if I want to do that, I guess I should divide every single function in its own file. That should be even way better, because I don't really like to encapsulate more than one function in a single file. Anyway, so well, let's just print out something like wait. So how do I address this guy? Is utilities dot utility dot mol and 2 and 4 and 7 and 3. And it's not warning me about anything, so I guess it's okay. Python 3 11 0 2 0. That's why. Oh, I think I know why. If I go to my utilities here, sum, there we go. Actually, I may like to change your to mol. A better name, and your initial value should be 1, because if you are multiplying by 0, I'm not getting anything. Num. Why is num no longer? Oh, wait. That's wrong. There we go. Okay. There we go. What's the thing here? Predefining mol from older scope. Yeah, I guess you're right. Well, not really. Why? Because it's going to be defined down here. Well, I guess. Okay, let's try again. There we go. So seems to be working right now. Okay. And now I'm going to see what's going on here. Okay, let's see. Well, this is wait, is this the right one? Okay, let's open this one. There is one. And you are coming with this guy. Okay. Well, I think these two can go together. The previous two could go together also, but I guess I messed up that opportunity. No, it's not this one. Hola, ma. ¿Qué? Ah, ya, gracias. Bien. ¿Vas a comer apenas o qué? ¿Ya? Ah, mira.
¿Tú?
Ya comí. No sé si querías platicar o algo.
No, voy a quitarme el uniforme,
Ah, está bien.
ponerme en la cama.
A echar un
descansar
rato. Dale,
Aquí ando, mi amor.
dale, ma. Hasta luego. Gracias. Okay. Okay, so I'm living with my parents. Okay. That's another comment. I wonder why it's red. I don't know. That's weird. Oh, because of this? Yeah, this is weird, dude. I mean, actually, I don't think I need the str. Probably the dondler method is going to fix it for me, but I don't know why. Well, now it's a change. Okay. Wait, before doing that, I may like to try. Okay, 3. Yeah, it's working. I don't know why. I'm going to add this as a refactor. Yeah. I don't know. Well, it says that sum is not an item, but it definitely is because I can actually run it. So I don't know.
Let's learn about different ways that we can actually import these modules. Up until now, we've only learned about import. But sometimes things can get pretty hectic. For example, we can actually have another package inside of another package.
Oh.
If, for example, I create a new folder here and say new Python package. We'll call this more shopping.
No.
Click OK. You see that
That's way too much.
Package inside of a package that has its own init file. And let's move this now to, let's do refactor, move, and we'll move it inside of the more shopping folder. So I'll say
Oh my god.
shopping. If I click OK, you'll see that I've moved this module over here. So I have a package inside of a package. And the way we access this is to say simply shopping dot.
It's an example, so it's okay.
Dot shopping cart. And let's copy that over.
Yeah. Oh my god.
And now when I click run, you'll see that it still works. But this is getting a little bit too.
Yeah.
You can imagine as we have more and more packages that we constantly have to do this dot, and this is getting a little too long and ugly. So
I think you can assign all of that in a
something
variable.
like this. Instead of saying import, we say from this part, I want to import the function. So here I'm saying, hey, from package name module, import whatever function I want. In our case, we want to import the by function. So you see here, I can just do that in my code. I can just run by as if it was the same file. If I run this,
Oh,
you'll see that it still
interesting.
works. Awesome. So that's definitely cleaner. And we can do this with utility as well. I can say from utility,
Just
and actually
import
import the two functions, or the two functions. So that is multiply, and if you want another, you can just add a comma and say divide.
Oh, from the
So now
same
we can
file.
print apple, or by apple, as well as divide. Let's say 5 by 2.
Oh,
And we
interesting.
can also multiply. Oh, and make sure it's a comma here, because it is a function like this. So that if I run this, you'll see that there we go. This works as well. So this is a really nice way to clean up your code. You can also do something like this, where you say from package name, and then import the entire module. So let's say I want to import the shopping cart module. I can say import, so package.package, or you could just have done one package, and import the actual module, shopping cart. So now I would access it like this, shopping cart.fly. And this is going to work as well. Perfect. Now the reason you might want to do this instead
Okay,
of...
wait. You say then shopping. Okay, more shopping. From this, import shopping cart. Yeah, that it is.
what we had before is that sometimes you can get name collisions. Let me show you. Let's say I had a print, and then in here we use the max function, which gives us, it's a built-in function, we give it an iterator, and it finds the max for us. So that if I run this, you'll see that the max in this list is 3. Well, imagine in our utility function, we have a, let's say instead of divide, or we add a max, that simply says, returns, and oops. Well, if I go back to my main.py, and get max as my function, and I click run, well, you see I get an error.
Yeah.
I get max takes 0 positional arguments, but was given but
1.
because now max doesn't mean what we thought we meant, at least in this file. We imported max, and well, max is a whole different function now. So we can actually override.
Okay, so
by using something like this, shopping cart, we make sure that we have only one case that we might have name collision, but all the properties or all the methods that shopping cart has are connected to shopping cart. So instead of having multiple functions that could be overridden, I only have one namespace. And by the way, this is also one of the reasons that I don't recommend doing something like this. You can actually import star. And what this says is, hey, from the utility module, import
everything.
And when you do that, you'll see that once again, we get an error because it imports the max as well. And because we don't even know what's being imported right now, we can't see it. We have to go to the file to see it. When we get an error like this, we're going to be like, what's going on? I thought max is working. And it's because of this line. So it's always good to be explicit and say exactly what you want.
Yeah, what you want to import.
Let's remove max for now. But as you can see, modules can be imported in different ways. My recommendation is to always be explicit and say exactly what you want to import. And the format usually follows either using the import statement followed by the package.module or import the module. Or you can do the from statement to give it package, subpackage, and module if you want. Or you can do module and then saying import and the specific function or the actual module itself. Many ways of doing it depending on your need. The key takeaway here is that modules and packages help us have good engineering practices and build big projects in an organized fashion, yet still have all these files talk to each other.
Okay.
That was a lot. Let's learn more in the next video.
Okay, cancel. Okay. That's interesting. Let's see. What the hell? Lol. Oh no. Yeah, I
No matter how
imagine.
you feel about the new currency, it is here
What
and
the
it's
hell?
growing. One of the more controversial
It's
digital
so
assets are
depressing, bro.
NFTs, a space
Why?
quickly dominated by feminist projects like remarkable women.
Okay, I'm going to ignore that one. Okay. what I'm gonna do, I'm going to take a break right now. But before that, I'm going to make another example file here. So let's see. 1103. Import. What was the name of the video? Different ways to import. Yeah, I like that name actually. Import.py. Okay, so let's see. I have a utility and actually the name is going to help me because it's going to collide. So initially I have like this utility. I'm importing utility from here, but I can change this to from utility import, and I think I could do say sum and mol. Mol is not there. Yeah, okay, but I got sum. And from what's the name, utilities, from this folder name, import. Oh, wait a minute. Okay, well, I could say utility, but that's going to create this issue that he mentions before. So I guess I could say dot utility, and from there I can just say mol, because I already know that what's going on here. Redefining built-in sum. Oh, there is a sum. Okay, never mind. Well, I guess I already overwritten that one, so it doesn't matter. The next one, what is it? Oh yeah, because it's not being used. Print sum 1 and 2, and print mol 3 and 4. So this is 11. Okay. Come on. Wait, what? Python 3.10? Python 3. Let's see. Oh, it's Python 3.10 already. Okay, never mind. Python 3, 11.3. Different ways to import. So 3 and 12. Okay. I think I'm getting the hang of it. Okay. Let's add this to the repo. Oh, wait. Cancel. There we go. Okay, now it's on the repo. And here, there we go. So let's create a git push. It doesn't exist, so I'm going to run this line over here. And it's going to create a merge request, I'm not going to, that's the nice thing about this merge request. I can open them, but I'm not required to create the merge request just yet. I can continue adding commits to this thing, so I'm going to be doing that. And later I'm going to create let's go back here. There we go. I have two branches now, the one for section 11 and the main branch. And section 11 is going to be deleted when I finish with it. But right now I'm going to take a little break. Okay, and I think I'm going to be back later for video gaming. Not really for learning, because my brain is like pretty tired right now. But tomorrow morning I'm going to continue learning Python. and stuff. So I'm going to sit down a little bit, take a rest, and continue later. I want to play King of Fighters maybe. So stay tuned.